Hello, students, and welcome to our lesson today. We're going to start something new today. We're going to begin evaluating expressions. We'll start, of course, as always, with our do now, and our prompt today is about something called relationship deposits. I'm anxious to talk about what that means. Our objective will be to evaluate expressions. And our essential questions are: what is an expression? Why is the order of operations important? And what does it mean to evaluate an expression? Our assignment is to answer the do now, and everything this marking period will be in your Q3 folder. So we're beginning our work for the third marking period. As we watch the video, we will complete the 2 pages on evaluating expressions, and we'll answer the exit ticket, and that's do now, and the exit ticket are done in teams. We do our math on paper. And most important, remember to show me your completed work. If I don't see it, I don't know that it's done. Our exit ticket today asks us to complete 2 phrases. The first one, an algebraic expression is, and to evaluate an expression, I must what? Again, show me your work. So if you didn't get a chance to finish this lesson, you can complete it for homework. If you finish it, then you have no homework tonight. So remember, for full participation credit, have your camera on, respond when your name is called, and show your work on camera at the end of the period. If you have trouble with that, you can send a photo to my email. If you have any questions, you can write to me. When you write to me, please have a proper greeting and closing in your email. I need to know who it's from. Sometimes you guys write to me and you don't even tell me who you are. And you just write, you ask a question, then you just end your email and press send. So, and then others of you have beautiful signature blocks, and I enjoy seeing those. Reminder that we still are doing full days of classes on Wednesday, even while we're distance learning. And we are going to begin map testing on February 4th and 5th. And I'm excited to see how much you've learned this year in math. So I'm excited to see how well you do. So there's our do now, our exit ticket, and these are the 2 pages that we will be working on today. So we have 16 problems. So we'll start with our do now. In our relationships with others, we can make deposits. Deposits are positive actions or words that improve our relationships. What kind of an act would be a good relationship deposit? Does a relationship deposit have to be hard? So think of those things you do to keep your relationships healthy and in the right direction, so that you understand each other, you're a good listener, maybe you help each other out, maybe you do favors. We call those relationship deposits. Sort of like you make a deposit in a bank when you want to save money. Well, when you want to save up goodwill with each other, you also can make a relationship deposit. So please put your answer here on these lines. We'll come back to our exit ticket later, but let's get started with our topic, evaluating expressions. So, what is an algebraic expression? An algebraic expression is an expression that contains one or more variables. And the variables, we use letters. So to evaluate an expression, you substitute the variables with their given values. So your given values in the problem. Then you evaluate by following the order of operations. I told you we were going to use this order of operations a lot, and you'll be using it a lot in your entire math career. Okay, so now in example number 1, it says 7x plus 4y if x equals 5 and y equals 3. So here's one way to handle this. Substitute parentheses for the letters, for the variables. Now, we had an x in this first space, and here it says x equals 5, and we had a y in the second space, and it says y equals -3. One great reason to use parentheses when you substitute is to keep those negative signs orderly. So this is 4 times -3. If we didn't have the parenthesis, you might think it was 4 minus 3, and that's an entirely different thing. Okay, so now we're going to start to evaluate using the order of operations. So multiplication and division before addition and subtraction. So 7 times 5 is 35, plus 4 times -3 is -12. And then 35 plus -12 is the same thing as 35 minus 12, which equals 23. Let's try the next one. Now, be very careful. We just want to substitute for A, and B will be, the exponent will be outside the parentheses when we do that. So A will equal 4 and B will equal 7. So we have 9A, and it says A equals 4, and that is squared, minus 2B, B equals 7, which is squared. So we start grouping symbols, exponents, multiplication and division before addition and subtraction. So grouping symbols, we don't have multiple terms inside the grouping symbol, but we do have exponents. So what is 4 squared? 4 squared is 4 times 4, which is 16, minus 2 times 7 squared, which is 49. Now let's take care of the multiplication here. 9 times 16 is 144. 2 times 49 is 98. 144 minus 98 is 46. Number 3, we have 4m squared plus 5m, and m equals -2. Be very careful with the negative number with this one. So let's rewrite the problem with our substitutions. We have 4 times -2, which will be squared, plus 5 times -2. So we'll start with the exponent because we don't have anything happening in the grouping symbols. So 4 times -2 squared, well, -2 times -2 is a positive 4, plus 5 times -2. 4 times 4 is 16. 5 times -2 is -10. And we can rewrite this as 16 minus 10. And 16 minus 10 equals 6. Now, number 4, we have 8 times the quantity of C, 8C, the quantity of 8C minus D, and that is divided by C times D. And we need to substitute 2 for C and 4 for D. So let's use parentheses carefully. We have 8C, which is 2, minus D, which is -4. Okay, so now we have double parentheses there. Now all of that is divided by C, which is 2, times D, which is -4. So I think where I'm going to start first is I'm going to go left to right with the multiplication here within these grouping symbols. Remember, grouping symbols first, exponents, multiplication and division before subtraction and addition. So I've got 8 times 2, which is 16. Now, minus a -4 is +4. And why am I doing subtraction or addition already? 2 things. First of all, this is inside a grouping symbol, so I'm doing the grouping symbol. The second thing is subtracting -4 is the same as multiplying -1 times -4, which would be a +4, which we divide by 2 times -4. Okay, so still working in those grouping symbols, we have 16 plus 4 is 20, divided by 2 times -4. Now we'll do 20 divided by 2 because multiplication and division are worked from left to right. It doesn't matter if the division is first or if the multiplication is first. So we'll have 10 times -4, and 10 times -4 is -40. So there are some tricky things going on in that one. Number 5, so we've got the quantity of AB squared minus 4B to the third power plus 1, and we substitute 3 for A and 2 for B. So A is 3, B is 2, and that quantity is squared. Minus 4, again, B is 2, and that is to the third power plus 1. So grouping symbols, exponents. I think what I need to do is work inside this grouping symbol here. 3 times 2 is 6. So I will have 6, and that is to the second power, minus 4. Now I've got another exponent here. 2 to the third power is 2 times 2 times 2, which is 8, plus 1. Now, 6 squared is 6 times 6, which is 36, minus 4 times 8, which is 32, plus 1. Now I just work from left to right. 36 minus 32 is 4, plus 1, and 4 plus 1 equals 5, our final answer. Now for number 6, we have absolute value. And we have 2 times the absolute value of r, and r is -5, minus 3 times r, which is -5, times s, which is 4. So let's first substitute. We have 2 times the absolute value of r, which is -5, minus 3 times r, again that's -5, times s, which is 4. Absolute value is a grouping symbol, so we'll work there first. So if we remove the absolute value bars, we have to determine what is the absolute value of -5, and the absolute value of -5 is 5 because it's 5 units from 0 on a number line. So we have 2 times the absolute value of -5, which is 5. We need to use parentheses or it will look like a 25. Minus 3 times -5 times 4. Now, 2 times 5 is 10 minus, and we have more multiplication here. We'll work from left to right. -3 times -5 is positive 15 times 4. And we have to do this multiplication. 10 plus 15 times 4, 60. 10 plus 60 equals 70. Okay, number 7. We've got w minus v, and that quantity is squared, plus 2 times v minus 7 times w, where w equals -1 and v equals 1. So let's start substituting. So we have w minus v, so that would be -4 minus 1. And this is one of the few times I didn't use parentheses when I substituted, because all I have there is w minus v, and I don't have a a double negative going on in the middle. I could have written it like this. And it would have been the same thing. But in this case, I can take those parentheses out. So now we have plus 2v, which is 1, minus 7w, which is negative 4. So first I'll work with this group over here. So negative 4 minus 1 is negative 5, and that will be squared, plus 2 times 1 minus 7 times negative 4. Now I've got an exponent, so I'll work with that. Negative 5 times negative 5 is positive 25, plus, we have multiplication here, 2 times 1 is 2, minus 7. So if I took minus 7 times minus 4, that would be a positive 28. So I still need to do this addition, and then the addition that was created by multiplying the negative times the negative. So 25 plus 2 is 27, plus 28, and 27 plus 28 equal 55. Number 8, we've got a fraction, that's okay. We have 8 times 2/3 x squared of x equals 6 minus 5x, and x equals 6 plus 8. So let's substitute first. 2/3 6 times 6 squared minus 5 times 6 plus 8. So we start with the exponent, 6 squared. So we have 2/3 times 36. 6 times 6 is 36. Minus, and we've got multiplication here, 6 times 5 is 30, plus 8. Now, 2/3 times 36. I'm going to come over here. 2/3 times 36. Well, we can put a 1 under there, and we can cross cancel. 3 goes into itself 1 time. 3 goes into 36 12 times. When we multiply across, 12 times 2 is 24 over 1, which equals 24. So this part, 2/3 times 36, equals 24, and we have minus 30 plus 8. So 24 minus 30 is negative 6. Negative 6 plus 8 equals 2, our final answer. Okay, so number 9, we have two substitutions, 3c to the second power, and c equals negative 3 minus c, negative 3. So we're going to subtract a negative here. We have to be mindful of that, which is multiplied by d, which is negative 2, plus 7 times negative 2 to the second power. So this problem is all about very careful substitution. So we have 3 times negative 3 to the second power minus negative 3 times negative 2 plus 7 times negative 2, which is raised to the second power. So let's work with these exponents here and here. Negative 3 times negative 3 is 9. So we have 3 times 9 minus negative 3 times negative 2 plus 7 times negative 2 to the second power. Negative 2 times negative 2 is 4. Okay, so let's work with this. We have 3 times 9, which is 27, minus -3 times -2 is a positive 6, plus 7 times 4 is 28. So 27 minus 6 is 21, and 21 plus 28 is 49, our final answer. On number 10, we have a square root. We haven't done many of those, but I'll show it to you now. The square root of 3p, if p equals 10, minus q, if q equals 14. Okay, so that's the amount that's in the square root here. Then from that we subtract p squared, p is 10, plus p times q. So let's get started. We've got the square root. Let me work a little neater than that. We have square root of 3 times p, which is 10, minus q, which is 14. Okay, then we subtract p squared, which is 10 squared, plus 10 times 14. So we'll start we'll work within the radical sign first. And within the radical sign, we'll do the multiplication. So we have the square root of 3 times 10, which is 30, minus 14. And we can also do this exponent, minus 10 times 10, which is 100, plus, and we can do this multiplication, 10 times 40, which is 140. Let's go back to the radical. We have the square root of 30 minus 14, which is 16, minus 100 plus 140. The square root of 16, well, what do I multiply? What times what? These being the same number equals 16. And the answer to that is 4, because 4 times 4 is 16. So we have 4 minus 100 plus 140. And 4 minus 100 is negative 96 plus 140 equals 44. So only 6 more problems left. Number 11 is division problem, 2ab divided by 7b minus a squared b, if a equals 3 and b equals 12. So try some of these on your own and come back to the video and see how you did. So I'm going to make the substitution, 2 times a b divided by 7b minus a, which is squared, times b. All right, so let's start with the numerator. So we can multiply 2 times 3, which gives us 6 times 12. And in the denominator, we can multiply 7 times 12, which gives us 84, minus 3 times 3, which is 9, times 12. And then in the numerator, we will have 72, because 6 times 12 is 72. Then we will have 84 minus 9 times 12, which is 108, which equals 72 over 84 minus 108 is negative 24. And 24 goes into 72 3 times, and a positive divided by a negative is a negative. So our final answer is negative 3. Number 12, m equals 2 and n equals negative 9. So where we see m, we substitute 2. Where we see n, we substitute -9. So 2 to the 4th power minus 2 to the 2nd power times -9 to the 2nd power. All that is divided by 2 times 2 minus 2 times -9. So where to start? We start with those exponents. 2 to the 4th power is 2 times 2 times 2 times 2, which is 16. 2 to the 2nd power is 4. And that is going to be multiplied by -9 squared, which is -9 times -9, which is a positive 81. In the denominator, we have 2 times 2, which is 4, minus 2 times -9. So -2 times -9 is positive 18. So in the numerator, we'll continue with the 4 times 81. So 16 minus 4 times 81, which is 324. And 4 plus 18 is 22. And 16 minus 324 is -308. And that's divided by 22. And if you divide 308 by 22, you'll get 14. And if you divide a negative by a positive, you'll have a negative. So the answer is -14. Number 13, we're going to substitute x for -8 and y for -5. So 28 minus 4y, and that's our -5, raised to the 2nd power, divided by our x is -8 times y, which is -5, minus 2 times -8 squared. So we'll start with our exponents. We'll have 28 minus 4 times -5 times -5 is positive 25. And in the denominator, -8 times -5 is positive 40, minus, now we have an exponent here, we'll do that next, minus 2 times -8 times -8 is positive 64. Next, going back to the numerator, we have -4 times 25, so 28 minus 100. And in the denominator, 40 minus 2 times 64 is 128. 28 minus 100 is -72. 40 minus 128 is -88. Then here, a negative times a negative will equal a positive. And both of these numbers are divisible by 9. 72 are divisible by 8, are divisible by 8. 72 divided by 8 is 9. 88 divided by 8 is 11. And it's positive because a negative divided by a negative is a positive. And now number 14. We're going to substitute r for 7 and s for 2. So r is 7 squared times 2 squared minus 22. And in the denominator, 7 squared minus the quantity of 2 to the 3rd power plus 5 times 7. So let's start with those grouping symbols and exponents. So in the numerator, 7 times 7 is 49, times 2 times 2 is 4, minus 22. In the denominator, 7 times 7 is 49, minus, now in here we have 2 to the third is 8, plus 7 times 5 is 35. And then we'll work with that, and we'll also multiply 49 times 4. So 49 times 4 is 196, minus 22, and in the denominator we have 49, minus 8 plus 35 is 43. And then 196 minus 22 is 174. 49 minus 43 is 6. 174 divided by 6 is 29. Our last two problems. 3/4 times C, which is 2/9, minus 1/6 times D, which is -4. So we'll substitute first. 3/4 times 2/9 minus 1/6 times -4. Okay, first thing we need to work with is this 3/4 times 4/9 times 2/9. I'm going to bring it over here. 3/4 times 2/9. Now 2 goes into itself 1 time. It goes into 4 2 times. 3 goes into itself 1 time and into 9 3 times, which equals 1/6. So I simplified that right away. Minus, now we have 1/6 minus times -4. So 1/6 times -4, we'll put that over 1. 4 and 6 are both divisible by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So 1 times -2 is -2. 3 times 1 is 3. So this will equal -2/3. And I have a feeling I'm going to wish I left that into 6. So let's convert that right now. That will be 1/6 minus, and if I make the denominator 6, 3 times 2 is 6, 2 times 2 is 4. So minus 4/6. Now, the next thing is when we subtract a negative, it's the same as adding a positive. So we make those positive. I'm going to rewrite that here. 1/6 plus 4/6. And that's an easy add. 1/6 plus 4/6 equals 5/6. And that's our final. Okay, so here we are at our last problem. We have one substitution, 1/4. And that will go wherever we see x. So 5 times 1/4, and that is squared, minus 10 times 1/4 plus 3. So first we start with this exponent. So we have 1/4 times 1/4 equals 1/16. So now we have 5 times 1/16 minus 10 times 1/4 plus 3. So 5 times 1/16 is 5/16. And 10 times 1/4 is 10/4. So 5/16 minus 10/4, and then we add the 3. So in order to subtract 10/4 from 5/16, we're going to have to convert that 10/4 into 16ths. And we need a new number for the numerator. Well, we know that 4 times 4 equals 16, so we'll multiply 10 times 4 to get 40. So we're going to rewrite this as 5/16 minus 40/16. And I'm also going to convert the 3 to 16ths. 3 over 1 equals something over 16. If I multiply the 1 times 16, I multiply the 3 times 16 to get 48. So I converted the 3 to 48/16. Now that I have 16ths in the denominator, all I need to do is 5 minus 40 plus 48. And 5 minus 40 is negative 36 plus 48. And negative 36 plus 48 is, negative 35. Sorry about that. I knew something was wrong. Negative 35 plus 48 is a positive 13. So the numerator here is 13, and 13/16 is our final answer. That was a tricky one, and I hope you kept up with that. So let's go back to our exit ticket and fill that out. Okay, so here we are. An algebraic expression is an expression that contains one or more variables. To evaluate an expression, I must substitute the variables with their given values, and then I follow the order of operations. So there you have it. Make sure you show me your work, no matter how much you got done during the period. Keep practicing. You've been working really hard, and I'm super proud of how well you're doing. So keep at it, and you'll be great.